This is our frame. This is our framework flower generation algorithm, and it's by Paul Bay, Tim Kai, Ford Bennett, and Lucy Zhang. So what this algorithm is doing is it's using a TensorFlow machine learning GANs. So what this GANs does is so we're feeding in 8,000 photos of 107 different species of plants or of flowers. Excuse me. So and after it's been fed these 8,000 photos of plants, the GAN stands for generative adversarial network. So it is generating new images based off of the images it's given, and afterwards it is putting the new generated images against the original photos, the photos of the real flowers themselves, and it's judging whether or not the generated photos are good enough to trick the discriminator. So what the discriminator does is it discriminates whether or not it judges whether or not these images are flowers. Are they good enough to be flowers? So it's just what this model is doing is it is generating new flowers and putting these new flowers and putting them new flowers against the original flowers and trying to trick the system itself. So using that algorithm or in that model itself, we created these three images. We set the epoch size as 3. What an epoch is it is the amount of times the GANs the model itself will go through all the images forward, so all of them forward once and then form again or backwards. So 3 times, that means it goes through all the 8,000. It goes through 8,000 photos 6 times, so forward and back. And then we set the batch size as 256. What the batch size is it is the amount of photos it does at one time per epoch. So 256 means it duplicates all these. It doesn't duplicate. 256 means it grabs the first 256 photos of the 8,000 image set and it judges them, and it does the next 256. It does the next 256, and then once it goes back again, it restarts from the end and goes back. So these first 3 we did not using Google Cloud Services. We used our local computer. So it took a long time, and we just got singular colors. So we got flat colors. And this next one, we started to use Google. We used a VM VM Google Cloud Service, and we can see that there is some change. You can see like different colors and some sort of a background, and then we up the epoch, and then we lowered the batch size because we realized that batch size correlates with the clarity of the image, and the epoch size correlates with the size and the shape of each individual kind of combination of pixels. So this is the 4th iteration. This is using Google Cloud Services. This fifth iteration, we lowered the batch size again, and we could see that there's a less clarity, obviously, between these two. But it takes a slightly less amount of time. And then afterwards, up the batch size, we get more clarity. We're using the same virtual machine. We didn't go back to our laptops because it was just too slow, and we're not able to create this clarity. It's only done with Google Cloud Service. The 7th, we up the epoch and up the batch size, and then we can now see we can see shapes, we can see different colors and kind of some sort of variety within these images. The 8th, we up the batch size, we kept the epoch the same. We can see like more defined shapes, but still less. There's not a lot to see. It's very difficult. And the 9th one, 500, 220 or 24 size. Still, it's difficult to see, make anything out. In this next one, we up the epoch size again, and we double the epoch size from this to this, and we can see a large variety of different colors and shapes. And this one, we up the for the 11th iteration, we up the badge size, and now we're getting more defined shapes and sizes. This last one, this one took an hour and 30 minutes, but we are now able to see shapes and like flowers. And all we did, we upped the epoch size and upped the badge size using the GAN's data algorithm. And we were only able to do this because of the Google Cloud services. We could get into their virtual machine. So,